In this lesson, we will talk about the least squares regression line. Most of the time, we'll just shorten that as LSRL, or if I screw it up, I sometimes call it LSLR, which is, of course, not right. This is the correct way to shorten that. Here we have a scatter plot. This shows the association between the protein and fat in some selected items from a national fast food chain. So we have this scatter plot, and this one already has a line on it, but if it didn't, or if I had to draw my own line, how would I know which line to draw? Well, this one obviously has a positive linear association. My R value is 0.76, but what line should be drawn in here? In order to draw the line, we are trying to find a line called the least squares regression line. And here's how we do it. It's made up of all of the points x comma y hat, yes, we call it a hat, where y hat is our predicted value. So our predicted value is found by our equation. And our equation, we've already sort of found it on our calculator before and haven't really talked about it, but the equation that is best fit, also called a best fit line, is found by basically analyzing the residuals. So a residual is essentially the distance between the actual value, which is x comma y. So in this case, here's my x comma y. It's the distance between that value and my predicted value, x comma y hat. So this is a residual. That's the distance. Now, because we're taking y minus y hat, so the actual value minus the predicted value, if my actual value is below the line, I will have a negative residual. And if my actual value is above the line, say from here to here, this would be considered a positive residual. So it's important to understand residuals. To find those values, essentially we would find the residuals for all of our data points, which of course we will not do by hand because that's ridiculous. And then we're going to square each value because we want all of the values to become positive. We're going to add them up to find the sum. And then whatever value that is, we're trying to find the smallest one of those. So if I drew the line up here, would I have more, a greater residual or less residual? So that's why it's known as the least squares regression line, is essentially we're trying to find the least value when we find the squares of the residuals, if that makes sense. So the best fit line is where we can basically make our residuals as small as possible. The equation that we use is similar, again, and we talked about this in our last video, it's similar to slope-intercept form, y equals mx plus b. Essentially what we're doing is y equals b plus mx. And the reason that we switch the order around, it's not just a, hey, let's just do this to be different. It's because when we actually do this in statistics, y hat is actually, we're going to actually put a variable name here. And x, we're actually going to put a variable name here. And so these are not going to be variables, they're going to be the name of the variable. So this would be like protein, because that's our x value. And this would be predicted fat, which would be fat hat. B1 is the slope. So just as before m is the slope, we're just calling it B1. Up here, this would be our y-intercept. That's essentially what this is, B sub 0.